High throughput drug screening is where we want to go with our current model system. We want to not only screen the lung and brain SCLC organoid tumors with standard of care like etoposide and platinum-based therapies, but we want to also look at other new therapies, novel therapies that maybe no one has thought of using in the clinic, and see if certain molecular subtypes of this tumor respond well to a certain treatment versus others, and really be able to, take this down that route of personalized medicine for the patients.
When people are talking about all these models, we sort of take for granted the fact that we all are plating in this 3D matrix that provides us with a physiologic feedback. When you do a 2D patient-derived line versus a 3D patient-derived line, the number of drugs that the 2D line responds to versus the 3D responds to are very different. And then there are a couple where you will have an inverse where in general the organoid is less sensitive and the 2D line is more sensitive to everything, but there'll be a couple where they're switched because the matrix is creating a vulnerability. And the better the models, the more we become dependent on the structures that hold them together, right? So if you're doing a complex skin model versus just a simple tumor organoid, those types of matrix components are fundamentally important.
As interest in organoids is expanding and more researchers are starting to utilize them, both from mouse and human, what we're finding is that now many companies are developing products specifically geared to organoids. Whether this is something like having tailor-made medias, which makes it much easier and accessible to a wide audience, or whether having new microscopes that can either live in incubators or that are specifically designed for organoids, that can monitor organoids in real time. Those are really kind of things that are now helping improve our ability to assess and do screening-based methods.
The aspect, I think, to improve the drug screening with organoids, we're developing special plates that really fit your needs for the drug screen itself. In my case, this was a 1536 row plate that needed to be developed. Beside this, I think liquid handling is one important step. Obviously, having high humidity incubators is key. And I think a robust setup for your automation is just important here.
Significant impacts in screening, mostly all the automation. So everything's, even your drug dispensing, your plate reading, everything's automated. And then organoids, Matrigel, organoids, the whole system works really reliably. You can have patient cells with ease. These are things we couldn't do, years ago. And so it's really changed the field. And it's exciting to, not always just rely on cell lines, to have 3D models with, a better tumor microenvironment, so we can really see more reliable results.
So there have been quite a lot of tools now that are developing, both in equipment but also in plates. The plates are now more organoid specific. When we made the first organoid, there was no specific organoid equipment, of course, because we were the first one making them. And actually that was a problem because a simple example is ultra-low attachment plates that were rarely used back then, but were key to organoid research. Since 2009, there has been an enormous increase in the number of resources that have been generated by the supporting companies that we now use in screening regularly, but were not existing 10 years ago. And hopefully we'll have a lot more in the coming years.